This project is an end-to-end time series forecast system with API. Here I follow production-ready MLOps pipeline. I first generated the data and models, then output through interactive backend and frontend. For that, step 1 is to do an environmental setup. So created and activated a virtual environment and installed all the required dependencies. These are the required dependencies. Then I do data pre-processing. The script transformed the raw Excel file into a cleaned, feature-engineered CSV. It handled data formatting, state-wise partitioning, and lagged feature. Descriptive statistics for the data are done and the values are generated. Thus, the pre-processing is done and a processed data.csv file is generated. Next step is to train the models. So for that, run the train.py file. The script iterates through all 43 states, trains the 4 mandatory models and evaluate them and calculate the RMSE values, that is root mean square error values, and save the best model for the each state. Best model is calculated based on the lowest RMSE values. Each state calculates the RMSE values for each model and you can see the difference here. After training is done, it populates the model directory with .pkl files, that is models. Now let's move to backend logic, where once the model is saved, start the inference server. Run the main script in the UVCon web. It will help start a server. I am using FastAPI here to host the models. When the server starts, it loads the saved artifacts into memory with near zero latency. A web is opened in the browser to see interactive API documentation. Type docs on the URL and click enter. This documentation page shows the primary endpoint, which allows any client to request a forecast by simply passing a state name. Here I am entering California as the state name. Execute it and we can see the response. Here code 200 means the response is successful and you can see the model type as XGBoost and they have predicted 8-week sales predictions. Now let's open another browser and enter another state name. I am entering Alabama. Execute it and we can see the response as similar to the previous. The backend returns a standardized JSON response. It includes the forecast value and the specific model used. In this case, it is SARIMA model. Finally, let's look at the presentation layer. Build with Streamlit. This dashboard is designed for business stakeholders who need a clear visual summary of sales trends. For that, run the command streamlit run app.py, which open a new browser and launch a dashboard. Here, when I select a state, the frontend send an asynchronous request to the FastAPI backend. In this case, I am choosing Texas and generate the forecast. API identifies XGBoost model is best for Texas, predict the 8-week forecast and return the data. Thus, we can visualize the trend to view projected demand of the sales. So through this project, I have designed a service-oriented architecture transitioning from ML experiment to a production-grade software engineering service. Thank you.